Right, welcome to Shabita Uganda e-learning, and my name is Nelson Bitswamba, and in today's video we are going to make a continuation of the questions that our questions about subsets and finding the number of subsets within a set. We are able to look at different questions. That was question 1 and question 2. So in this video we are going to look at these other questions, that is going to be question 3 and 4, trying to see how they always trick to check someone's understanding about finding the number of subsets in a given set. Okay, let's get started. That was a recap of what we did. Finding the number of subsets where we used the formula of 2 to the power n, and we are able to understand and see how we can be able to solve that. So we looked at now finding the numbers of subsets. That was our question that we are given, and we are able to find out our question 1 and our question 2, giving out this as solution. That was in our recent video. Please, if you didn't check out, be able to check out that video. You'll be able to understand more. So in today's video we are going to look at our question 3, question 4, question 5, question 6, and all we are to form what we call subsets. I mean finding the number of subsets within these questions. So our question 3 is here. We have our set M is having an element in it, that is a cow. Then also we have our set N, which is question 4. It is having the prime numbers less than 10. Okay, so we are going to see how we can find the number of subsets within these two sets which have been given. Okay, so let's get started. This is our question, and I've been able to put it under the activity. So let's look at this question. Our question 3 is having set M with an element called the cow. So they want us to form the number of subsets which are going to be in our set. Okay, so let's get started. Let me get a pen here. Alright, in our solution of solving this number 1, we are going to get our set M. Okay, our set M is going to be equal to the element which is there. Of course, that is the element, and we said that for us to know or to find the number of elements in a given set, 1, we use a formula which is 2 to the power n. Okay, where our n, where our n is the number of what? The number of elements. Okay, our n is the number of what? Number of elements in that set. Okay, our n is the what? Is the number of elements in that set. So that comes now to also find the number of elements. For us to find the number of elements of set M, we shall be able to say number of elements of set M is going to be equal to 1. Okay, so when we know the number of elements, then it becomes simple for us to solve such a number. So that means our 2 to the power n will be equal to our 2 to the power 1 to power 1, which is the number of what? Number of element. And this is going to be equal to any number power 1 is that number. Like we said in our recent video, that any number that is powered to 0 is 1. Also here it is the opposite. Any number to power 1 is that number. All right, so that means we also have to take note of this, such that when it comes and you find when a number is powered to 1, it should remain exactly that number. Also, let's look at our number 4. Our number 4 here, let's look at it here. Have our number 4. In our number 4, we have been given a set. Our set n is equal to a set of prime numbers less than 10. Okay, we have a set of prime numbers. Okay, our set is prime numbers less than what? Okay, less than, let me say less than 10, using that simple. So first of all, we have to understand what are these prime numbers. Okay, we should be able to understand what are these prime numbers. Now, for us to handle these prime numbers, someone with an idea about prime numbers? Yes, someone with an idea about prime numbers? Okay, that's right. Anyway, prime numbers, these are whole numbers that are greater than 1, and they have 1 and itself as their common factors. Hope we also looked at finding the factors of numbers and also prime numbers. So we shall be able to check out on our playlist for you to get more understanding about prime numbers. But don't worry, we shall be able to see how we get a prime number. Okay, as I've said, that prime numbers, these are whole numbers. They are whole numbers which are greater than 1, and they are evenly got by a factor of 1 and itself. 1 and itself. So we shall be able to see what are those prime numbers. Okay, so we are saying the prime numbers are numbers which are whole numbers which are greater than 1, and for us to get these prime numbers, should be able to know that that number, when it is divided by 2, that is an even number. When it is divided by 2, it should give 1 and itself. When a number is having more than 2 factors, when a number is having more than 2 factors, that number does not qualify to be a prime number. So that means we shall also be able, we shall also need to know how do we get a factor of a number. Okay, so let's start with that, such that we can be able to identify these prime numbers. Okay, let's start with 1. But remember, they are saying our prime number, this is a number which is greater than, it is a whole number which is greater than 1. So we shall not start with 1. Let's start with some other numbers. Okay, let's start with a 2. Okay, so we are saying we want to first get the factors of what? The factors of these numbers, such that we can identify if a number is having more than 2 factors. It's not going to be what? Not going to be a prime number, because they have said a prime number, these are whole numbers greater than 1, and they are got by dividing them by 2. Then 1, that is going to be 1 and itself. So we are going to try out our 2 here. We are going to try out our 2. When we divide our 2 divided by 1, we get our answer as what? Our answer is going to be 2. Okay. Also, when we divide our 2, by 2, we are going to get our answer as what? As 1. Okay, so here now we can see the factors of our number, which is 2. We are having these factors, a 2 and a 2 and 1. Do we still have any number that we can divide by 2 and it gives us another number which is not less than 2 or 1, it isn't there, it is not there. So that means we have our 2 which is having factors of 2 and 1. That is it is having a 2 and what, and a 1 and itself. So our 2 here is going to qualify to be a what? To be a prime number. Okay, so here we are going to say our n. Okay, our n is going to be equal to the prime number that we have got 2. Then also let's try our 3 here. We are going to try our 3. We are looking for those numbers when they are divided by when they have 1 and itself as their common what? Their common factors. So we are going to try out a 3. When you try a 3 divided by 1, we shall be able to get 1. Then also when divide a 3 by 2, of course we get a 1 and remain with something. So also that one doesn't qualify also to be what? To be a prime number. Also let's divide a 3 by 3. When you divide a 3 by 3, we shall also be able to get our 1. Okay, when you divided a 3 divided by 1, we are able to get a what? We are able to get a 3. Then a 3 divided by 2, of course that is we get a remainder, so that one is disqualified. That doesn't have any other factor of 3 apart from a 3 divided by 3. We get our factor, we get 1. So this means when you go further and divide a 3 by 4, it doesn't it gives us remainders. So that one meaning that one, the factors of 3 is a 1 and a 3. So that means it has 1 and itself. Those are the factors of 3. Let's also try out our 4. Okay, let's try our 4. What is 4 divided by we are now getting the factors of what? The factors of 3. I mean the factors of 4. 4 divided by 1, we get 4. Okay, we get a 4. What is 4 divided by 2? 4 divided by 2, we get 2. What is 4 divided by 3? Impossible. It is not a factor. What is 4 divided by 3? That is, it is impossible. That is not a factor. Then 4 divided by 4, we get 1. So we can see that a4 is having factors 1, we have a 2, we also have 4. So we said that a prime number, these are numbers that these are whole numbers greater than 1, the whole numbers that are greater than 1 and have factors which is 1 and itself. So we can see that our 4 is having more than what? More than 2 factors. It has a 4 and it has a 2 and it has a 1. So that means it has factors, but these factors are more than 1. So it doesn't qualify to be a prime number because it has more than what? More than 2 factors. Alright, so a 4 is disqualified. We said we got a 3 which was also part of our prime numbers. A 4 has failed. We go to a 5. We go to a what? We go to a 5. What is 5 divided by 1? 5 divided by 1, we shall get 5. Then what is 5 divided by 2? Which is impossible. 5 divided by 3, it is impossible. 5 divided by 4, it is also impossible. Also 5 divided by 5, we get 1. 5 divided by 6, that is impossible. Okay, so we can see that a 5 also is having only 2 factors, 1 and it's what? Itself. So also a 5 qualifies to be a prime number. Let's also come to a 6. What is 6 divided by 1? 6 divided by 1, we get a 6. 6 divided by 2, we get 3. 6 divided by 3 we get 2. Then 6 divided by 4, impossible. 6 divided by 5, that is impossible. Divided by 6 we get 1. So you can see also 6 has more than 2 factors, so it does not qualify to be a prime number. Let's also go to a 7. What is 7 divided by 1? 7 divided by 1 we get 1. Divided by 2, that is impossible, we get a remainder. Then also, what is 7 divided by 3? It is also impossible. Divided by 4, also impossible. When divided by 5, it is impossible. By 6, it is impossible because it has a remainder. And also when you divide it by 7, we shall be able to get our 1. So also 7 qualifies to be what? To be a prime number. Okay. So using that method, you can be able to prove whether a number is a prime number or it is not a prime number. Also, when we try 8, of course 8 has several factors. Also, when you try a 9 also has 1 and itself. 9, let us try 9. When we divide, what is 9 divided by 1? We get 9. Okay, we get 9 by 2, impossible. By 3, what is 9 divided by 3? Our 9 divided by 3, what do we get? Someone with an answer? Someone with an answer? Okay, we can see that also our 9 is having very many factors, because when you divide a 9 by 1 we get a 9. Also when you divide 9 divided by 3 we get by 2. We say 9 by 3, that is by 2 we get that is 6. Okay, so we shall get a 3. Okay, then 9 divided by 9. So we can see that our 9 is also having a factor, that is 1. We have a 3 and 9. Okay, so these are factors. You can see that it is having more than what? More than two factors. Okay, so we can also now stop at what? At 7. That means when you need all the factors that are less than 7, we shall be able to stop at what? I mean factors which are less than 10, we shall be able to stop at a 2, a 3, 5, and 7. So these are our what? These are our prime numbers. So now what is remaining is to form a what? Is to form to find the number of subsets within our set, which is n. Then using our formula, which is 2 to the power n, then our number of elements in our set n. Okay, number of elements in our set n shall be equal to, let's count them. They are the first element, the second, the third, and the fourth. They are going to be equal to 4. So that means 2 to the power 4 is going to be equal to, that is 2 4 times. Okay, 2 how many times? 4. Okay, 2 4 times. So we shall be able to get our answer as what is 2 times 4? That is 4. 4 times 4, we shall get our answer as what? As 16. So finally we can say the number of subsets that we have been able to get from our set n are 16 what? 16 subset. Don't forget to write what? Subset, such that your answer is not left hanging. Okay, this is how we can finally get the number of prime numbers. I mean the number of subsets within our number. So be able to know how you can find a prime number. They can either say our set is equal to a number of, let me say, a number of even numbers. They can say our set n is even numbers less than 10 or greater than 10, or less than 5 or less than 6, something of that kind. They can either give you odd numbers, they can even give you, let me say, composite numbers, something of that kind. We should be able to find out and know if they talk about a composite number, what is it, what does it mean? If they talk about an even number, what does it mean? If they talk about integers, what do they really mean? Those are the tricks that they can ask when it comes to finding the numbers of what? Numbers of subset in a given set. All right, hope everyone has been able to get this and understand how we can be able to get the numbers of subset. We shall be able to proceed to our next number, which is 5 and 6, and that is going to be in our next video. For this, I do say thank you very much for becoming part of this lesson, and be able to check out on our playlist for you to move at the same pace with us. Please don't forget also to subscribe for you to get some more upcoming lessons on this platform. Nice moment. Stay blessed.